Okay, so I think I had to go this way. All right. About me, so I'm a senior SQL Server consultant, like I said, at Microsoft. I have more than 10 years experience with SQL Server. I started, maybe most of you are more veterans than me. I started my career with 6.5, so I know people who even started like 3.5, but yeah. So I started with 6.5, and since then I worked with several companies, several big financial companies, like to name a few, KPMG, New York Life, and CSC, and things like that. I did several roles, including DBA, lead DBA, team leads, and then finally senior consultant for SQL for Microsoft. I'm an MCM, I'm Microsoft Certified Master. How many of you know about MCM? In show of hands. Not very. So it's a very esteemed D certification for appropriate technologies. There is an MCM for Exchange. There is MCM for SQL Server. So this is not like your regular MCITP or MCDBA. So if you go to Microsoft Learning site and you go to MCM, you'll see my name there as well. But you'll see there are a few MCMs. So these MCMs, we go through a rigorous 1-month training at Redmond with product team. Followed by a series of exams, and then followed by a lab and all that. So it's a little hard to get to, but it's not that hard, I can say. But yeah, so it's a very esteemed certification. I'm proud to say that I had that. MCT, I'm a Microsoft Certified Trainer for the last 5 years. So I did several workshops and developed and delivered several workshops as an MCT. I'm a clustering SME in my team, so I'm known as, anybody has any clustering cousins, and anybody has, not only my team, some other teams that I know of me come to me about any clustering cousins. So I'm known as a SME for clustering. I participate in the development of SQL clustering workshops. So PFE team has this clustering workshop, which is meant for to get more knowledge about clustering in the field. So they have a 3-day workshop. So I developed some of the topics and some of the labs in that workshop. I'm also a technical reviewer for Alan Head's the Pro SQL Server 2008 Failure Clustering book. I don't know if anybody knows, but it's a very good book. So I'm a technical reviewer for that. And then, like I said, I developed and delivered several custom workshops, including SQL clustering workshop, SQL Server for Oracle DBAs, things like that. So I did some custom workshops that are not available by default, or something customer wants that's not available by default. So I did some of those. So that's my story and my team story. Well, consulting for IT operation, that's what the name of the team, also known as OpsCon. So we are between PFE and MCS. So we do these focused SQL Server reviews, mostly post-operational reviews, though we do also do architectural and pre-implementation reviews as well. But we do most of the time our standard signature reviews or post-operational reviews. And we have a team of individuals in appropriate technologies like SQL, Exchange, AD, security, and even more vital. So we have individual team leads, individual experts in each of these. So we have several years of experience on how to manage, optimize IT services. So we use that experience. So when we go to the customer, review their operations, so we use our experience to see how we can optimize your environment, how to get the best out of your environment and your IT operations. So we not only focus at the technology, we also look at the people and process, because that's also important along with technology. So we have this that expertise that maybe not other teams doesn't cover, but we cover the ITSM process along with the technology to get the best out of your IT services. So we have multiple operational reviews. The most important and very popular one is a performance and scalability review. So we do, most of these are 1 to 2 week reviews. So we go to the customer, we assess their environment, identify where the bottlenecks are, where the problems are when it It could be to technology, people, or process. We identify all those, and we come up with all the recommendations, and we help the customer implement and give guidance on how to implement those. So that's what we do in a nutshell. So, but we have individuals. So we have performance and scalability, design and migration, high availability, where we cover the clustering part. Of course, clustering we cover in almost each and every part of the things, but we have one directly focused on clustering and database mirroring and any basically bringing the availability to the SQL Server environment. Disaster recovery and consolidation reviews, and also SAP health check. So I know some of the customers I worked with here, I have some familiar faces here. So I did some of this SAP health check and architecture reviews. And in addition, we do custom engagements and workshops as needed by customers. So anything that not falls into the arena of PFE or MCS, we go and help the customer. We develop custom engagement and help the customers. So if anyone wants more information, so we have these data sheets for all these reviews we do. So if anyone is more interested, want to know, so feel free to email me. Now that you know my email ID, so I can provide you all the information you need. All right, so these are the things we are going to cover. So we are going to go with the overview. How many of you, I know most of you have clustering implemented. How many of you not have clustering, SQL Server failover clustering implemented in their organizations?
How many do not?
How many not? Yeah, not, okay. Yeah, because I know very few. So I know most of you are already familiar with clustering, already using clustering, but there are very few that doesn't know. So I'll try to go, the overview I'll try to go past very quick. We'll also look at some of the benefits and limitations, and then we look at the failover processing. So throughout all this, we are going to use Windows 2008 and SQL Server 2008 as the Windows 2008 cluster with SQL Server 2008 failover clustering on it. So I have clustering set up on my using VMs on my external hard disk here. So I'm going to use those for my demos. So we'll look at the failover process and how to control and configure the failover process, how to prevent unnecessary failovers. We look at all that, and then we look at the some of the Windows 2008 improvements with respect to failover cluster, and then we'll also look at SQL Server 2008 enhancements that are that use Windows 2008 enhancements to get better availability for SQL Server 2008. And then we are going to look at the pre and post installation requirements. So what are the things you need to ensure? So because this is where I see most of the times customer fall short of. Preparation is the key, but most of the time that doesn't go the right way. So we're going to look at some of the most important pre-installation requirements and the post-installation requirements to make sure your cluster is robust and working good. And then we're going to look at the installation procedure. So how many of you worked with the SQL Server 2008 cluster? How many of you worked with SQL? Okay, good. So very few. So this is going to be interesting. So we look at what are the differences between 2005 clustering and 2008. So there are even installation procedure is different. So we look at that and followed by a demo. So I'll show you I'll walk you through the installation steps, and we'll actually try to install. I said try because it's VMs we are talking about. So I don't know how they behave. So I tried, I did a practice run, it did work, so I'm hoping it's going to work. So let's see how that goes. And then rolling upgrade and update. This is another very important key feature for clustering. We want customers to focus on this. So this is one thing that is missing for a long time. So how to prevent downtime or minimize downtime, increase availability while we are patching your SQL Server. I know when Windows patching, you have the ability to fail over, do the passive node and fail back. That was not available so far with SQL Server SQL Server. But 2008, that is changed. So we're going to talk about those. And then we're going to look at some of the cluster maintenance, troubleshooting, and last but not least, the best practices. Some of the best practices to maintain and optimize your cluster environment. So we'll talk about those. So this is the agenda. Any questions so far before we go into the meat?
Hey, can we breeze through the overview part pretty fast?
Yeah, that's the plan. Yeah, I know that's why I asked for. Most of the people already know about clustering, so we'll go breeze through this. So yeah, so failover clustering, it provides high availability for SQL Server, not only SQL Server, for different types of applications via fault-tolerant hardware and resource virtualization. That's how you get the availability part of the clustering. It's an integrated component of Windows, and it is available. It's a very proven technology. It's right there since 1996 with Windows NT Enterprise. So it's a very robust and proven technology. So in the capabilities, so every node has a full connectivity in communication with the other nodes. How that communication happens? Where the shared storage, and the shared storage can be shared SCSI, iSCSI, SAS, or fiber channel for the shared storage, and then a network communication between. So with that, cluster is going to know about what are all the resources available on each of the nodes participating in the cluster, who owns what resources, who is running, who is failing. So all that is controlled, and because of this communication that happens through the shared storage and the private network. And of course, one or more public networks for your actual communication with the databases or what are the applications you have in the cluster. So every node knows when another node leaves or joins. So all the communication is controlled via a set of managers. We're going to look at some of the cluster components, failover manager, resource managers, and things like that. So all those controls and aware of who is joining the cluster, who is leaving the cluster, what resources are owned by what node, and all that. So. And every node knows about the resource on its locally on its node, and on the resources on other nodes as well. All because of this shared communication happening, which is not new. So this is everybody, most of you know. So what are the benefits of the clustering? Why do you need clustering? It provides you, it reduces downtime, improves availability in several cases. What are those cases? Hardware failure. So it provides you when a node fails or any component of a specific node fails, you will still have availability of your application. There will be minimal downtime while it is doing the failover and all that, but after that, it is going to be available immediately. Within a few seconds or few minutes of downtime, you will have your applications available on other node while you're fixing this one hardware. Same thing with software failures. So OS corruption or driver corruptions or whatever on a node that may bring the node down, taking all its applications with it. Your cluster will be able to provide you high availability by failing over and moving those resources to a different another working node. So you'll have very minimal downtime. Same thing, patching and upgrades. Again, so 2008 until 2008, you could only do cluster can only provide you availability during patching and upgrades at the OS level, not at the SQL Server level. But in 2008, that's changing. So you can still provide increased availability even when while you're doing patching and upgrade. Site level failures, that is, if you're going with a global clustering, geosynchronous clustering, stretch clustering, you can also provide protection against site failures. If your entire data center had a power failure or something, you can have another node available somewhere in a different data center, so it provides you availability. So all these scenarios, cluster will be able to protect you from downtime. Unattended, so this is, you don't need to do anything special. The failover and the availability of the application happens seamlessly for the most part. There are some applications that are not cluster aware, which you may need to do some manual, you may need some manual intervention, for example, resetting the connections and things like that. But for the most part, cluster is seamless, transparent, you want to know that cluster failover happened, but your application, your users need not know. They will be working with, other than that small downtime, they will be working seamlessly. Their application will be up and running for them. Right? Hardware redundancy, so no single point of failure within a cluster. Increase scalability as well. If you're adding more memory, more CPU, so scale up and scale out. So it helps you with both. So if you want to do scale out, if you want to add more nodes, you can do that. In 2008, in fact, there is no downtime for that as well. You can add and remove nodes with Windows 2008, SQL Server 2008, without any downtime to the application that are already running on the other nodes. And then scale up. So if you want to increase the memories, processor speed, and things like that, so you can do that with minimal downtime. And this is instance level redundancy. So that is one more confusion I see about customers when they're talking about what high availability solution that they need to use. If they are looking for instance level at the SQL Server instance level, this is the only one that can provide you. If you're looking at the database level, then you have database mirroring, log shipping, and all that. But if you're looking at the instance level, clustering is the only one that can provide you instance level redundancy. So every database in that instance will be available as part of this clustering. So that is one thing we all need to be aware of when you are making decisions on what high availability solution you want to go. So these are some of the limitations. It's not going to completely eliminate downtime. There will be minimal downtime while resources are being moved, because the resources need to go down on one node, and then the resource need to be brought up on the other node. So there will be minimal downtime, but it's not completely eliminating the downtime. Your disk is so you still have some single point of failures. So your disk is your single point of failure. So if your disk fails, if there is some problems with your SAN or your disk spindles, then you still have, your clustering is not going to protect you, because you have a single disk, shared storage. So each node can only see one set of disk at a time. So even if there is a failover because of the disk failure, even when the resources are coming online the other node, they cannot work because the disks are gone, so they cannot work. So a single point of failure at the disk. So that's why you have to make sure. So yeah, this is an interesting thing. So one of the customers asked me, what we recommend normally is to make your disk subsystem as redundant as possible. For example, having dual fiber channel cards, or sometimes four, two dual fiber cards with 4 channels going to the SAN fabric. One of the customers asked me, why should I do that? I have a cluster, so they have one single fiber channel going from each node to the SAN storage. So I recommended them to have at least 2 for redundancy. So they asked me, so if that that fiber cord fails, it simply fails over, and the other cord will be working on the other node, so I don't have any problem. But I would say, yes, that's right, but then yeah, that will work. If the HBA cord fails on one node, and that's how clustering needs to protect you. So the hardware failed on that one node, so everything will be moved. But why do you even need to have that small downtime just because of the HBA failure? So if you have 2 HBAs in a load balancing and redundant fashion, configured using multipathing software and all that. So even if one HBA fails, or if the cable disconnect or whatever for that one HBA, you will not have a failover. You will not have any, not even a small downtime caused by the failover, because you have the other cord protecting you. So so you need to have dual fiber cord. So that's how I convinced the customer to go with. But yeah, so you need to provide redundancy as much as possible. Just don't take your cluster as your redundant solution. You need to provide other levels of redundancy as well. Things like fiber HBAs, dual fiber HBAs, dual NIC cards, or sometimes even 4 NIC cards. So provide as much redundancy as possible, so you don't even have to have that failover and the small downtime caused by that. So that's the thing. Limited network failure protection, same thing. If the network fails, you'll not be, even if the failover happens, you'll not be able to connect to your cluster, so there is no, application will be still down. And failover time. So how long the failover takes? Most of the time, it takes maybe a minute, half a minute. It all depends. But it all depends on how long SQL Server how long it takes to recover. So any transactions that are running at that time, so they all will be, need to be rolled back. So when the resources move over, when the SQL Server starts, it needs to go through the recovery process, right? So as many transactions you have in a limbo at that point of failure, they need to redo and undo all that. Of course, SQL Server 2005 onwards, you have that capability where only after the redo is done, you will have your availability of databases. You don't have to wait until the undo is completed. But there is still, so it all depends on how many transactions are in the middle at the time of the failover, how many needs to be rolled back, and how long they take. It all depends on that. And no load balancing. This is another interesting thing I keep hearing with the customers. So customers assume that SQL Server clustering is like some other competitive products. It's load balancing. It can provide you load balancing. So which means what they mean by load balancing is you can have same instance running on multiple nodes, and you can connect to simultaneously. Like if one node is busy, it has too many connections, and then the remaining will be going to the other node, and so on and so forth. There is no such capability. So it's only failover. It's only redundancy, no load balancing. Though you can get limited load balancing manually with the clustering. For example, you have multiple standalone SQL Server instances, right? And so to provide failover, so they're all standalone. So to provide failover capability, to make sure they are highly available, you can tie them together to get the high availability provide the cluster instead of leaving them standalone. So it has instance 1 on one box and instance 2 on another box. In fact, yesterday I was someone asking if I can do, and I told him yes, you can. So you can have you can tie them together, and of course with SQL Server 2008 or Windows 2008, it can be heterogeneous. They don't need to be equal, exactly identical, both servers. They can be heterogeneous. So you can have them tie them together and provide failover capabilities for both instance 1 and instance 2. So that's how you can get failover. At the same time, what I'm talking about load balancing is if you have one huge instance with multiple databases, of course you have to do some manual thing there, but you have multiple databases catering to multiple applications. You may distribute that into multiple instances and provide clustering, having each instance on each node. So you kind of get load balancing, right? I mean, it's manually. You can. It's not that easy, but it's possible if you have multiple databases in one instance, and each database has, unless if the database has some interdependency, like each database 1 depends on database 2, or some communication goes on between them, then you may need to do some synchronization mechanism. But if you have those databases used by multiple different applications, you can separate them into multiple instances and provide some kind of load balancing using clustering. But there is no load balancing built into SQL clustering by default. But you can do things like that to get that. So there is some naming confusion in the field. So it is failover clustering. It used to be called MSCS, Microsoft Cluster Server, and there used to be SQL Server failover clustering. And the SQL instance on the cluster used to be called as virtual server, SQL virtual server, because it's a virtual IP and virtual name. So they used to be called virtual instance. But those names are gone because they are conflicting with other things. Like for example, we now have the virtual server, the virtual server technology. So the name is called virtual server when you're using VMs, Microsoft Virtual Server. So to avoid any conflicts, we don't call virtual instance for SQL Server. For SQL instance, we call failover instance, SQL Server failover instance, and then. MSCS is called WSFC, Windows Server Failover Clustering. And another very important thing is about active, passive, and active, active. We still use those terms, but we strongly recommend against using those terms for SQL Server failover clustering. Why? Because there is no active-active in case of SQL Server failover clustering. Like I said, there is no load balancing, right? It's all failover. So at any given point of time, each SQL Server instance can be active on one and only one node, right? So if you have a two-node cluster and you have two instances on each node, customers tend to call it active-active. But that's not the case. Instance 1 is active on node 1, and it's all passive on node 2. So it's still an active-passive. So that's the active-active is the term that gives some false notion about load balancing and all those things. Not only that, now you can go up to 16 nodes cluster with in a complex cluster environment. You have so many instances, and what are you going to call them? Active, 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 passive, active, 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 or active, passive, active, active, active? What are you going to call, right? So it's going to give a lot of confusion and a lot of problems with calling it. So we strongly recommend not to use active, 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 passive technology. Then what should you use? Multi-node, multi-instance. So if you have 3-node cluster with 2 instances, 3-node, 2-instance cluster. I know it's easy to say active-active than 2-node, 3-instance or 3-node, 2-instance, but that gives appropriate name, and that tells you exactly how many instances you have, how many nodes you have. So to give that clear distinction, we recommend you to use multi-node, n-node, n-cluster, n-node, n-instance cluster. 3-node, 3-instance, 3-node, 4-instance, so on and so forth. So please stop using active-active and active-passive technology. All right, so nothing to do with network load balancing, compute cluster server, as we already talked about. All right, so here is how a typical clustering configuration looks. Because, yeah, you're providing redundancy at the SQL Server level, but what about all other things that depend on SQL Server that requires, availability as well? So in a typical configuration, you will have like something like this. So your firewall and your application server can be done with the network load balance cluster, NLB cluster, and then followed by your SQL Server in a MSCS or failover cluster configuration. So that's how a typical 2-node SQL Server cluster environment looks. You may be familiar with this with your clusters. All right, so cluster models. So there are there are so many combinations you can do with cluster. You can play around with the cluster configuration. So very typical, the most common one that we come across is the 2-node, 1-instance cluster. So you have 2 nodes in a failover cluster combination with a shared storage, and you have 1 instance, and then so that instance, this indicates the preferred node of the instance, which is this node here. So in case of any problems with the hardware, anything on that node, the instance will be moved on to the other node. So that's 2-node, 1 instance, or previously known as active passive. And then you have 2-node, 2 instance. So this is how it looks. Well, actually, no, 3-node, 2 instance. But yeah, you can have another instance. So most of the customers, instead of leaving this idle, so customer tend to use that for another instance and then call it active-active, but it's actually 2-node, 2 instance. So which is perfectly all right, because this node is idle there, not doing anything until a failover happens. So you can effectively use that by installing another SQL Server instance. But you have to make sure you are taking proper precautions. In the event of failover, you have appropriate resources available on each node. No doubt, it's going to be in degraded mode. So at one point, so if you have 2 instances on each of these nodes, if this node fails, both of the instances will be on one node. So both instances will be using all the resources on that one node. So you will have some performance issues. Your instance will be in degraded mode. So you had to cater to the needs. So you have to make sure that you're appropriately configuring. You're reserving enough resources. Your minimum, maximum server memory settings and all that need to be appropriately configured for each instance. So in the event of failover, you still have appropriate resources available for both instances. No doubt you had to waste, I don't say waste, but you had to reserve some resources, but it's better than reserving an entire node, right? So instead of reserving the entire node, you just reserve some memory resources, CPU resources, and things like that. Mostly memory. I mean, CPU, you can just leave it default, unless you want one instance very critical and it wants to get all the resources. You can kind of minimize, do affinity, CPU affinity. But most of the time, your minimum and maximum memory settings are the ones that you need to play around to make sure that you have enough available. Well, if you don't want that, you want both instances to be highly available and highly working all the time, then you can look for this configuration: 2 instance, 3 node, 2 instance. So in this case, this node and this node are this node is a preferred node for the instance 1, and this node is a preferred instance for instance 2, and this will be your failover node. So that you'll be reserving that. Yes, there's a question.
From a licensing perspective, is this configuration okay for standard edition with the 2 active nodes and the 1 node for failover?
Standard only allows 2 node, so you cannot have a 3 node.
So you can't have one that's not passive?
No. So because it only allows, you can only, even when you are installing, well, you can do this. Yeah. So what standard does is it will not let you have more than 2 in the possible owner list. So if you want to have this, so if you, for example, instance 2, you only want to fail over to the middle node, then yes, you can configure the standard instance because you can't fail over to instance 1, node 1. Let's say this is node 1, node 2, node 3. So if instance 2 is a standard edition, you can have node 2 and node 3 as a possible owners, leaving node 1. So anytime instance 2 will be failing over to node 2.
So basically the third node would be your passive node for both of your instances.
Yeah, the middle node is a passive node for both of the instances. That way you can configure standard. But the main reason why most of the customers go with this is they want to provide they don't want to have the degraded mode in an active configuration. So for example, instance 1, node 1 fails here. Instance 1 fails over onto node 2. That's fine because there is no one else is there on that, so everything looks good. But what if instance 2 fails, node 3 fails at the same time, which is very rare, but node 3 fails. Where it fails, it goes to node 2 again, right? So you still get into the degraded mode. So what customers do is this way. So if instance 1 is on node 2, and at the same time if instance node 3 fails, you can set it up in such a way, there is an anti-affinity class name, we'll talk about that. We can set it in such a way that instead of instance 2 failing over to node 2, it fails over to node 1. So that way, you still have only one instance on each node, but you still have the failover capabilities, and you have better performance. You don't have degraded mode. But if you're looking for standard SQL Server, you cannot do that kind of magic. You can only use one node as a failover, so there is a chance that both instances can maybe failing over onto the same node, causing degraded mode. So that's, but yeah, other than that, yes, you can do that. Any other questions? Yeah, you can also do three node 3 instance. If you don't want to even waste that one node, you can have 3 node 3 instances. And then there is other types, n+1, so multiple active nodes and one passive node or inactive node, n+1. And then there can be n+i, very complex cluster configurations can have like this, multiple nodes with, this is where that anti-affinity class name really helps you. So we'll talk more about that, what that is. But yeah, that helps you to make sure that no two highly active instances are on the same node to prevent you from the degraded mode. So we'll talk about that. But these are the different types of models possible with cluster. So these are the technologies, and when you're talking about cluster, these are the technologies that you need to be aware of. cluster node, the physical server, cluster group, where your application, your disk, where the resources are. So collection of resources is a group. And then cluster resource, each individual resource, each SQL server is a resource, agent is a resource, so all those are resources. Heartbeat is your communication between nodes to make sure that they are alive. So it's a communication, heartbeat communication. We'll look in the next slide about that. Resource dependencies, the dependencies. So agent needs to depend on SQL Server. So the parent and child resource relationships to make sure that all the child resources are up and running before the parent comes online. So those are the dependencies you are already familiar with. Failover, failback. So failover is the problem, and you're going back to you're moving to a different node. Failback is going back to your preferred node. So if you have a preferred node that you always want your SQL Server to be running from, so once the failover is done, you can also set up a failback window, so it automatically fails back at that window. So once the preferred node comes online, so failback. Shared disk, all the disks that are shared between the nodes that host your databases and things like that. Those are shared disks. There is a witness disk. This is it's kind of analogous to quorum. So in 2008, Windows 2008, the quorum concept is changed. We'll talk about that. So instead of calling it quorum disk, we call it a witness disk. So if you're configuring a disk as a quorum, like a quorum in SQL in 2008, Windows 2008, we call it a witness disk. Yes.
Does that just begin to muddy the waters between clustering and mirroring?
Are you asking me?
Yeah.
You're asking if we are going to cover both?
No, wouldn't that just, you call it a witness, wouldn't that just muddy the water between
Oh, okay, the term witness, right?
the term witness?
Well, witness disk, witness server, right? I mean, witness is a common term. So yeah, there are conflicts like that everywhere. So we call it witness disk. So, but in the case of mirroring, it's a witness server, witness. So yeah, that's a good point though. It can cause some confusion, but the reason why it is a witness here, so we'll talk more about this, the quorum concept, then you know. So I don't see any other name better for that. So, but I'll make a point of that. I'll make sure that it goes to the appropriate people. Yeah, that's a good point. Quorum, so there are different types of quorum. There are 4 types. Until Windows 2003, there are 2 types. The regular disk-based quorum and then majority node set. There are 2 more added into Windows 2008. We'll talk about that. And then, of course, the public-private network. So these are all the cluster terminology you should know about when it comes to clustering.
Do you still have quorum? You said witness is equal to quorum.
Yes, but so it's the concept is called quorum. So there is no physical thing called quorum. In Windows 2003, you used to have a disk that has all the cluster database and cluster information, all that. That used to be called as quorum disk, and it's called quorum. Now in Windows 2008, there is no such physical thing called quorum. The quorum is a concept here. Quorum is nothing but a consensus, the majority and all that. So that's the concept is still there, but there is no physical thing called quorum disk.
Is there a physical thing called a witness disk?
Yes. So the quorum, previously known as quorum disk, is now called witness disk. All right. So heartbeat. Well, it's the same. There is one major difference with when it comes to heartbeat in case of Windows 2008. So heartbeat, as everybody knows, which is what is going to ensure that the nodes are alive and running. So every time, so in a single node, 2-node cluster, so there is one heartbeat signal goes from one node A to node B every 1 second, 1,000 milliseconds, which is configurable, by the way, into Windows. Actually, in Windows 2003, it is partially configurable. In Windows 2008, there are more configurable parameters, so you can configure that. But by default, it is every 1 second. So every 1 second, node A sends a signal to node B saying, "Are you alive?" So that's a heartbeat. right? So, and node B in response to that sends an acknowledgement back in there saying, yes, I'm alive. So when that fails five times in sequence, then that's when node A thinks that node B is down. So if node B is down, so node A sends 5 times, once every second, a heartbeat asking, are you alive? When for all the 5, it doesn't get a response, then it knows, okay, so within 5 seconds, then it knows, okay, that node is down. Now I need to do something to do an arbitration process to identify what resources were running on that, and then bring them online on the appropriate nodes. So all that, so the heartbeat helps you to identify if a node itself fails and it's not available, so this heartbeat helps. Now the change, I told you there is one major change to Windows 2008, and that is prior to Windows 2008, the heartbeat signal, this communication used to be a UDP broadcast. Now it's a UDP unicast. Why? Because UDP broadcast are not, most of the routers don't favor the broadcast. They block the broadcast. So in Windows 2008, the key is to make multi-subnet clustering, where you need to have the signal cross through routers, which is not possible, which is possible, but it's very problematic with UDP broadcast. So that's why now the heartbeat has been changed to UDP unicast. Well, at the time of creating and configuring the cluster, it's still going to use TCP/IP to do the initial communication, like sending the synchronizing the registries, sending the registry hive, creating the cluster database, and all that happens through TCP/IP. Once the cluster is configured and stabilized, and from that point onwards, this heartbeat will be happening via UDP unicast on port 3343. So you want to make sure that if you have some firewalls and things like that in the middle, you're yes.
Can you still configure it as multi-customer?
No, you cannot. No, you cannot configure. It's a UDP unicast by default, and it's not configurable. And it's always used 3343. But you can configure. So when you're talking about multi-subnet, this 1 second may be a too short a time for the heartbeat. So you can configure that. You can go up to 4 seconds. So you can do a in subnet within in subnet configuration and out of subnet configuration. So in subnet you can have up to configure it to 2 seconds. So you can make your heartbeat send and wait for every 2 seconds. In case of multi-subnet or out of the subnet, you can go up to 4 seconds. So you can configure that. Yeah.
In reality, how far can you put the nodes apart?
It all depends on how far you can survive the heartbeat, how much latency you have. So as long as, for example, you can provide your latency between the nodes less than 4 seconds, that you can send a packet from here to there within less than 4 second delay, you're okay with that. So it all depends on what kind of network you have between and what. So all the thing is, heartbeat should never miss. Well, 1 or 2 may miss, but the subsequently 5, and that is also configurable. So if you think you want to be immune to even more than 5 subsequent heartbeats fail, you can go up to 10. So 3 to 10. So minimum is 3 and maximum 10. So if you set it to 10, then only when 10 subsequent heartbeat fail, then node decides that it is failure. But you want to be very careful when you're doing that, because you're giving 10 seconds latency there. So if your node really fails, you're waiting for 10 seconds before it is detected and failed over. So you're okay with that or not. So you have to make sure properly before you tune those parameters, you make sure that you're taking care of those. Yeah?
Is that heartbeat set so you can configure what port it goes over, or is there standard port that
3343. 3343. Yeah. Yeah, so it's 3343, so you want to make sure that you have any firewall exclusions. You need to make sure that you're doing that. And that's not configurable as well. UDP unicast 3343. All right? Any additional questions on heartbeat? All right, quorum. So, like I said, quorum is now a concept. No longer, there is no physical thing called quorum. So quorum basically says how many, what are all the things that the cluster service need to have to maintain the cluster, to maintain the operation functionality of the cluster. So how many nodes For example, how many disks should be available before cluster decides that, okay, now it's, I don't have enough enough witnesses, so I need to go down. So the quorum is the one that maintains the cluster availability, the cluster service availability by looking at certain things, and those are by voting. So basically, the quorum, like I said, it's a consensus. So you need to have more than 50% consensus across in your cluster. So you have multiple nodes. So you need to get your cluster services need to get more than 50% consensus out of all those nodes to maintain running of the cluster. So anytime if you have equal to or less than 50% consensus, then your quorum is not achieved. So basically it says there is no quorum is not achieved. So there is a quorum manager that decides to bring the entire cluster down. So that's why so this quorum is important. So how does consensus achieve? By voting. So there are three things that can vote: nodes, witness disk, and file share. So these are each node can provide one vote. Actually, not the node, but the system drive on the node. So the node may be up, but the system drive is down. It's not possible, but then there is no vote from that. So quorum manager seeks votes from each of the up and running cluster components. So one is the node. So each node that is running, functional, having system drives available is going to send one node. And witness disk. So this is the quorum disk we talked about. So each witness, of course, there can be only one witness disk in a cluster. So witness disk sends one node. And then there is a new thing called file share witness. So in 2008, there is a file share witness, and that file share witness can send one vote. I'll talk about what the file share witness is. So anytime, so let's take an example. You have 4 nodes, right? And you set it to a node majority quorum, right? We talk about different types, but each. So you have 4 nodes, and let's say you don't have witness disk, you don't have file share. So each node is going to send one vote, and if 2 nodes are down, so how much consensus you have? 50%. That's not enough, right? So then the cluster is going to go down. So on a 4-node cluster, if you don't have witness disk, if you don't have file share witness, at any given point of time, at least 3 nodes should be always up and running. So that 4-node cluster can protect you from 1 node failure, but not more than that. So anytime if the one more node goes down, your entire cluster goes down. So so that's how the concept. But if you have 4 nodes with a witness disk, then how many nodes can go down? 2, right? So you have 5 votes now, right? 4 nodes, each node is giving one vote, and the witness disk is giving 1 vote. So that gives you 5 votes. So out of that, 2 can go down. So 3. So if even 2 nodes go down, 2 nodes with plus 1 witness disk is going to give you the consensus. So that's how the quorum is maintained. But let's talk about the different types of quorums to understand. Disk-only quorum. This is the quorum, the default quorum in Windows 2003, which is not recommended now. So in 2003, you have one disk called quorum disk, and that should be always up and running for your cluster to be available, right? No matter how many nodes you have 4 nodes, let's say, and if that one disk goes down, quorum disk, your entire cluster goes down. But that's not the case in Windows 2008. So if you set it to node and disk majority, which is the recommended one, I'll talk about that, then even if that witness disk goes down, your cluster is still up and running and alive. So that's the reason to prevent that single point of failure caused in 2008, we have this new concept, quorum concept with multiple types of quorum nodes. So we strongly recommend not to use this disk-only quorum. The next one is node majority quorum, which is the same as majority node set quorum in Windows 2003. So this is mostly when you have odd number of nodes. So when you have, let's say, a 5-node cluster. So you don't have to have a witness disk. You can set those 5 nodes to a node majority. So anytime if 3 nodes are up and running, you have a quorum and your cluster is up and running. So this is similar to MNS, multi-majority node quorum in 2003. This is the most common one, node and disk majority. So if you have even number of nodes, like in case of a 2-node cluster, so you can set up a one disk as a witness disk, and that's what I have in my demo that I'm going to show. So you can set up one disk as a witness, and then anytime, even if one node goes down, you have two votes, right? The remaining node and the witness disk. So you have a quorum. Even if the witness disk goes down, you have two nodes up and running, so you have a witness. So if one node and the witness disk goes down, then you're in trouble. So that's the node and disk majority, and that's not. So when you have even number of nodes, so when you're configuring cluster, by default, cluster is going to select one of these four, depending upon what kind of cluster you have. If you have a 4-node cluster, it's going to go with the node and disk majority. If you have witness disk, if you have odd number of nodes, it goes node majority, things like that. Now, node and file share. This is a new one, and this helps you with your multi-subnet clustering. So when you have, clustering across multiple data centers. So when you have a witness disk, if you are configuring a witness disk and you have one node sitting somewhere in another data center, and if this data center fails, and your witness disk is configured here, your witness disk goes, your nodes go, so you don't have any quorum. So your cluster will be entirely down, right? So you're not getting that advantage of the multi-subnet cluster. So you can set up a file share on some other server which is somewhere else. So it can be an external. So somewhere on the server, there is a server lying maybe in a different data center with a disk and everything. So you can set up a file share. You can create a file share like a regular file share, and then say use that for your witness. So then cluster can be configured to use that as one of your votes. So it seeks one vote from there, and it has all the cluster information. So anytime if that witness is available, and when the majority of the nodes, when you have the majority, then your cluster is going to work. So that's a file share. Yeah.
So witness disk is the same as the file share.
No, witness. Yeah, there is a file share witness and a disk witness. Disk witness is when you have the shared disk, just like quorum and shared, that's called disk witness. A file share witness is when you have a file share configured. There is a disk somewhere, and you create a file share over the network, and then you can use that for your witness. So when you have multi-site clustering, that's when you use. Yes, sir.
So you have to use either witness disk or the file share witness. You have to.
Yeah, you can. Yeah, good point. You can only use either witness disk or file share witness. You cannot use both.
But you have to have either one of it.
No, you can go with just node majority, but it's good to have. Huh?
But you have to have an odd number of nodes.
Yes.
But if you don't have a witness disk, where will it store all your cluster configuration?
In the local, so the quorum information, the cluster information is now stored in each and every node in the local system disk, in addition to the witness disk and all that. Good point. All right, so let me go real quick here. So yeah, so when a failover happens, you know this failover process. So I'm going to just breeze through this. So basically, so when a node fails, everything fails over to the other node, and you still have the connectivity because you're using a virtual instance, which provides you seamless connection. So this is all good. So lookalive and easylive. So these are the two things. How many of you don't know about lookalive and easylive with SQL Server? Don't know. How many of you don't know about lookalive and easylive process? So it looks like most of you know. So let me breeze through it. So basically, node heartbeat provides you the node level. If the node fails, the heartbeat is going to tell you a node failed or things like that, right? But if the resource itself fails, if the SQL Server resource fails, this lookalive and easylive is going to help you detect that. So every time, so in case of SQL Server, every 5 seconds, a lookalive signal will be sent. That basically looks for the cluster service goes and sees if the SQL Server service is up and running or not. So every 5 seconds, it sends a query to service control, Windows service control, to see if the SQL Server service is running or not. And then every 60 seconds there is an is alive. So lookalive is just a cursory check just to see, okay, your service is running or not. Is alive is going to run a select edit server name every 60 seconds on the instance to see if the instance is really up and running or not. Yeah?
Is it available both in 2008 and 2005 or is it?
Yes, it is available in 2000. So there is a lookalive and is alive. So I mean, normally you can leave it default, but times when you want to configure these, you can change the every 5 seconds, the skip period, every 5 seconds, every 60 seconds, you can change that. But this is how what it happens. So by default, every 5 seconds it sends a signal to see if the service is running or not. If the lookalive fails, then it sends an immediate is alive. So it's not going to wait for 60 seconds. So if the lookalive fails every 5 seconds, then it immediately sends a is alive to see if it can run a query. So if the service stopped for some reason, the lookalive fails, and then it immediately runs an is alive to confirm that, to try to run the select edit server name. If it's not able to run that, then it knows that, okay, it's down, so it's going to go through the failover process. So that's the lookalive and is alive. So yeah, so the failover mostly takes takes about 60 seconds. During a failover, users will not be able to connect. Any existing connections will be disconnected. They need to be reconnected. Most of the time automatically, but some non-cluster aware application, you may need to recycle the connections and things like that. All the transactions will be rolled forward, any incomplete transactions, and incomplete will be rolled back. So that's the failover process. So these are the cluster components, some of the most important cluster components: a failover manager, resource manager, and global update manager. There are more other managers in 2008. I don't want to go through all those. That takes a day to talk about those. Then the resource monitor, which is interacts between your cluster service and the resource DLL. And the resource DLL is, every resource either has its own, every clustered application either has its own resource, like for example SQL Server has its own resource DLL that comes with a SQL Server, or if you don't have, it can be using, any application that doesn't have a specific resource DLL, you can use a generic resource DLL that comes with cluster configuration. So that is the one that has all the checks about is alive and look alive. So this is how basically failover happens. So when a resource is offline, resource manager detects that error. It attempts to restart the service. So that's important. So in SQL Server 2008, the number of retry attempts is set to 1. In case of 2005, anyone remember what's the retry number of retries SQL Server tries to do in case of SQL Server 2005? 3. That's right. So if the SQL Server resource fails, when the resource manager detects that, it attempts to restart the number of times it is set in the failover in the policy, right? So in 2005 it is 3 times. So it tries 3 times, and if all the 3 retries fails within a specific period of time, then it tries to failover. In case of 2008, we decided to keep it 1 because if the resource failed 1 time, most of the time, even the subsequent retries will be failed. So why wait until do all those 3 retries and then wait? So it just, if 1 time the resource fails and 1 time the restart fails, excuse me, then it immediately starts failing over. So anyway, so if the retry limit exceeds, then it will switch all the resources and all the dependents within the entire cluster group. And if the cluster group is set to affect the group, so it's going to failover, it is going to turn off all those resources, and then it notifies the failover manager. So the resource manager notifies the failover manager, and then failover manager checks for certain window and failover constraints. And then when those constraints are met, and if it also checks, it will do the arbitration to see if any other node is available to host these resources, and it's going to bring those resources on that available node in the appropriate order. So that's how a resource process. Same thing, node failure, and I'm going to skip through this. So failover order. So these are the there are some changes to these things you need to know. Well, most of the time it's the terminology that changed in SQL Server 2008. It's the same concept, but the terminology, for example, there is no affect the group now. It's called, I'll show you in one of the policies, it's called with a different name. So preferred owners and possible owners, these are two concepts that you need to aware of. Preferred owner is not a mandatory thing. Preferred owner basically says, in case of a failover, what is your next in the order. So if you have two nodes, then you have, this is the order you are following. So whatever the resource on node 1 fails to node 2. So that's the preferred list. You don't need to have that preferred list unless if you have multiple nodes, and let's say you have a 3-node cluster, and you want when any resources fail on node 1, you want the failover to happen to node 3, then the preferred order will be node 1, node 3, and node 2. So that time, when the need resource on node 1 fails, when they decide to fail over, they first try to go to node 3, because that's the order. And if the node 3 is not available, then go to node 2. So that's how, so that is to control that failover order and failover destinations, you can use preferred node, but it's not mandatory. But the possible owners are. So the possible owner says, what are all the possible known owners available? And this is what I was talking about. When you have a 3-node cluster in a SQL Server 2005, you cannot have all 3 nodes available as possible known owners. You can only have 2, because you can only in standard you can only support 2 nodes. So you can only have 2 nodes in the possible owner. But the possible owner is mandatory, and that says how many how many nodes you have available for any resource to fail over. So if you only have one in this list, and all the resources on that node, if that node fails, they don't go anywhere. They just stay there, failed. So you have to have all the possible owners that needs to be set. And so the lookalive and isalive are not changed. The naming is changed. So lookalive is now called basic resource health check, and isalive is called thorough resource health check. That's the only difference. The name, but the concept is same, but the name has been changed. Say it again?
To protect the innocent.
To protect the innocent, right. Anti-affinity class name. How many of you know about this anti-affinity class name? Not many. Okay, so this is a very interesting thing. So I was talking about that 3-node scenario, remember? So when you have 2 instance, 3-node 2-instance cluster, and when node 1, the instance on node 1 fails to node 2, and at the same time, if the instance on node 3 is also attempt to fail over, you don't want it to fail over onto node 2, then you can set up this anti-affinity class name. This is basically a property in the group. There is no GUI way of setting this. You need to do it through command line. So for each cluster group, you can set up an anti-affinity class name, and you specify some string in there. Whatever you want, called critical, for example. So if that group is critical, you can set up a critical as the string name in the anti-affinity class name. So when cluster is when that resource group is trying to fail over, the anti-affinity, it checks for that anti-affinity class name, and it's not going to fail over onto the node that has another group with the same string. So if you have 2 instances, and you don't want those 2 instances to be on the same node ever, then you can set both the group properties of these 2 instances for the resource groups of these 2 instances with the same string as the anti-affinity class name, say critical. So then when this node 1 fails to, when this instance 1 fails to node 2, and when instance 2 tries to fail over, even if in the preferred list, if this node 2 is on the preferred list in the second in the preferred list, when it tries to fail over, it sees that there is already an instance on that. So it's not going to fail over onto that. It goes on to the other node. So, yes?
Is it case sensitive?
Good point. I'm not sure. But I'll check on that. I'm pretty positive it's not case sensitive. But, so the point is you have the same name on the group properties. So, but what happens if that other node is not available? So let's say it tries to fail to node 3. No, it's not going to stay down. It is going to ignore the anti-affinity class name. You don't want to have the failover just because the anti-affinity class name is, you don't have that node available. You still want to have the failover. Of course, you will have it will be in degrade mode, but you still don't want to have downtime, right? So it ignores that. So when it doesn't find any other preferred node or possible owners that are available without that the group, then it's going to ignore that anti-affinity class name and fails over to next available node. All right. All right, I'm going to skip the demo for now. Short of time, we'll do all at once. So 2008 improvements, no cluster HCL. This is something everybody likes. You know, in 2003, if you want to set up a cluster, your entire cluster solution should be part of that Windows Server catalog. Everybody remembers that? Anybody? So you're not just each individual server or each individual node, entire cluster up to the storage and what the storage drivers you're using, everything should be available as a solution in Windows Server Catalog. Of course, I know most of the customers ignore that, but when it comes to actual problems, when you seek Microsoft support, they may deny because you're not running a certified solution. So in 2008, you don't have that anymore. So you have this cluster validation wizard in 2008. So that helps you, so as long as that validation, so when you're implementing cluster, you had to run this validation wizard. And as long as that validation wizard is okay, it doesn't have any errors, it can have warnings. There may be warnings, but that's okay. But as long as there are no errors, you can configure cluster, and you're even SQL Server, you can configure SQL Server as cluster. So it can be a different server, different model, different numbers, anything, but the validation wizard need to succeed. All right. New quorum model, we talked about that. And the failure cluster management, completely redesigned. So no more the old clue admin. It's completely redesigned. It's a wizard based. Everything now is wizard based. You don't have to do most of the things. You don't have to do manually, even adding disks and things like that. So wizard based. Up to 16 node support and IPv6 and DHCP. So Windows 2008 now supports IPv6 and DHCP. Though we don't recommend using DHCP for SQL Server clusters, but it is possible. Yeah.
You have to work on a laptop, right?
Yeah. And multi-site failover clusters.
The limit on the distance between the sites.
Yeah, that depends on your heartbeat and your how far, how much you can survive the heartbeat communication.
Can be across the country.
Yeah, as long as you're within that 4 second and the default 1 second delay or 4 second delay, you're okay.
Do you have any customer right now to implement with different sites?
I know about. In fact, we have one of our application, our own Microsoft applications are across the continent. I don't know exactly which one, but I heard about that. Yes, we do. Yeah.
Does this span over multi-subnets or it has to be one subnet? All of those?
It can be, yeah, I'm getting to that. So Windows supports multi-subnet, but SQL Server doesn't. SQL Server not yet supports that. In future it may be. The reason is all dependencies. So to get the multi-subnet, you need to provide all dependencies. So everybody knows about dependencies, right? So you have a child resource dependent on parent, so you have dependency. Now in 2008 you have all dependencies, which means you can have 2 child resources. If any one of them is available up and running, the parent resource can be brought online. You have n dependencies and all dependencies. So that all dependencies what helps you with the multi-subnet. So for example, in a multi-subnet, you may have individual network IP addresses and everything, right? You cannot have same IP address. There are different IP addresses. So you can set up in such a way that you provide both IP addresses and dependencies with an OR clause. So at least one of those IPs available, your network name will be available, your SQL Server will be available, right? So but that's not supported in 2008. In SQL Server 2008, we don't yet support all dependencies, which is required for multi-subnet. So we cannot set up multi-subnet for SQL Server 2008 yet, but that will be changing soon.
What about shared disk?
The share,
Say if it's in 2 different data centers. Shared disk.
the shared folder witness.
Storage
Uh-huh.
is attached to the SQL Server.
Uh-huh.
Needs to go to the another data center.
Right.
So how that works?
Well, you have to have some third-party SAN level replication. So stretch clustering, you have to have individual SAN on each of the destinations, then synchronize at the SAN level replication, keep them in sync. So if this fails over, it uses the SAN on that side. So then you don't really have the shared storage, it's a individual storage, but you have to have SAN storage vendor interaction there. So you don't, by default, you cannot do that within Windows or within SQL Server. You have to have your vendor support there. All right, storage enhancements. There are a lot of storage enhancements in Windows 2008. The very important one is SCSI 3 persistent reservation. In case of Windows 2003, it is SCSI 2, what is it called? SCSI 2 release and reserve, which is not very robust. There are chances that even, you might have seen this, right? So you have one node that is claiming the ownership of all the disks, but at the same time, you'll also be able to see those same disks from other node. Anybody seen that kind of problems where it's supposed to be available from only one node, but I have seen several cases where the same storage, same volume, same disk is available from both nodes. It's visible. It doesn't work, but it's visible, and when you try to open it, it says it's failed. So all that happens because of that the reservation, the improper reservation or not very robust reservation with Windows 2003. So in SCSI 3 persistent reservation is more robust, and there is no chance of that. If one node is claiming ownership of the disk storage, that disk will not be given to any other node, period. So that is that SCSI 3 persistent reservation. And completely rewritten cluster disk driver, even the network storage driver, cluster disk driver, everything is completely rewritten from the ground up, which gives you better performance. And support for, there is no support for parallel SCSI. No, excuse me, no more support in Windows 2003 for the parallel shared SCSI. It's only now fiber channel, SAS, serial attached SCSI, or iSCSI. Okay. Now support for FAT32 partitions, and the witness doesn't require a drive letter. So most of the time you have this drive limitation. So Q drive, you always reserve that. You don't have to do that. You don't need, the witness disk doesn't need a drive letter at all. And adding additional disks is now online. You don't have to, no downtime while adding additional disk resources. So it's completely dynamic and online, so no more downtime there. And support for GPT, in addition to MBR, GPT disks are supported, so which means you can go up to 2 terabyte partitions. Simplified installation process, no remote execution. So these are the installation process. So there is differences to that. We'll talk about that in the next slide. And the integrated, so the SQL Server, these are SQL Server enhancements. So integrated operating system and SQL Server checks. So SQL Server goes through 3 individual series of steps, one for operating system, one for SQL Server, one for the cluster throughout your, so that makes sure that you don't have any failures, so your setup is fine, you don't have any failures, you don't realize the failures at some point during the setup. So every checks will be done before it actually attempts to install. So your setup failures are very, very, very minimal compared to SQL Server 2005. So this remote execution, so no remote execution is another thing. So there is no, so in 2005, if you have a, let's say 2-node cluster, you start installing SQL Server 2005 on one node, it automatically installs on the other node. On the, so it will do a remote execution using the Windows scheduler, and then both nodes will be available and with the clustered immediately after finishing setup. That is not there anymore. Windows 2008, it is strictly local because we had so many problems with that remote unattended installation because of the remote scheduler is not available, or the servers are so much secured that it doesn't allow any remote execution. So we had so many problems. So now you had to strictly run the setup on each and every node of your cluster. So you run this setup on one node and then go to the second node and add that to the cluster by running the setup again. So every node need to be done individually. And cluster validation report review. So the validation report I talked about. So Windows has this cluster validation checks, So SQL Server is going to review that report, and if there are no errors in there, only then SQL Server lets you proceed with this setup. If there is at least one error, warnings it's going to ignore. But errors, any red marks in that report, it's not going to let you continue with the cluster at all. All right. Let me start my VM here so I can show you this.
I have a quick.
Yeah.
We have a hard stop in like 6 minutes because we need to take care of so many things. But I know the demo is super important. I was wondering if we could do a live meeting session. Maybe you can do it and we can distribute the recording later. for the
Absolutely,
demo.
yeah, we
Is
can do
that
that.
fair, guys? Yeah. Because I don't want it to be like a 5-minute thing and we stop him. So
Yeah,
is that fair?
yeah, works for me. Yeah,
All right.
that's good.
So why don't we finish the slides and you promise the team that you will record it. I mean, you can record it on your own and send the link to the group.
You have a Bible?
About posting that on midnight DB.
Yeah, post it on Midnight DB. You're right.
I just volunteered to
So-
go, if you don't mind.
Yeah, I'll set up the live meeting part, and I can make sure that I'll take care of
Because
that.
most of us came as
Because-
a demo here for the setup.
Yeah, I understand
especially
that.
for the setup.
Yeah.
I mean, I did it once, but it was such a pain, and I wanted to see it one more time. So,
Okay.
so we didn't want to miss out or go faster.
Yeah. So definitely, yeah. I'm sorry. I thought I was breezing through, but I didn't realize that I have so much information to share. But let me go through that, and we will have the live meeting session with the whatever we are left. So okay. So another important thing is rolling upgrade and patching. So you can now install SQL Server service packs or patches with minimal downtime. So in case of SQL Server 2005, you had to install the patch, SQL Server patch on the active node, and the SQL Server is going to go down, restarts, and all that. But now you can actually install the SQL Server, the patches, service packs, or patches on the passive node, and then do a failover and do the patching on the other passive node. So just like your Windows patching, where you do on the passive node and then do the failover, similar thing you can do with the SQL Server. So that reduces your downtime. So that's I know that's very needed feature, and it's finally there. And yeah, add remove operations. If you're adding nodes, removing nodes, those are also dynamic. You don't need to bring any of your existing nodes down or any applications on the existing nodes down. They can be highly available because it only impacts your node that you're working on. So that's another that reduces downtime. And most of the Windows 2008 features are used by SQL Server. So for example, DHCP, IPv6, no more HCL. We'll talk about the services and maximum number of support. But there are a couple of things that are not supported. One you already know, which is that OR dependency. The OR dependency, so multi-subnet feature, that is not supported yet. Another thing is core. I know this is a very frequently asked question. Do we support SQL Server 2008 on Windows 2008 core? The core concept in Windows 2008, that is not supported. Not just cluster, even on standalone. So we don't support installing SQL Server 2008 or any SQL Server for that matter on Windows 2008 core yet. And of course, Hyper-V virtual machines, it is also supported. Stop me when I need to. Sorry. Slipstream and sysprep is supported. Slipstream is, if you have a service pack, you can slipstream, you can merge drop everything into one instead of running RTM setup and then SQL Server service pack setup, cumulative update setup. You need to, instead of doing all this, you can slipstream them, and SQL Server 2008 supports from service pack 1. In fact, my demo is going to be a slipstreamed version of SQL Server 2008 with service pack 1. So that is possible. Sysprep is not supported yet. It will be soon. So sysprep is basically cloning. You create one gold server, and then you clone that server, the installation of that and that server, then apply that onto multiple servers. So when you're talking about hundreds of, even tens or 20s of SQL servers you need to install. You can installing on individual one. You can use this sysprep to create a board build and apply. That's not supported yet. It will be soon. So Windows Server Core and multi-subnet is not supported, as I said. Okay, so what are the clusterable services? Just like before, SQL Server Agent, SQL Agent, analysis services. What is non-clusterable? Integration services, you can cluster manually. There is a procedure, though we don't recommend, but it's not by default clusterable. Reporting services and all this. Full text service is now integrated in SQL Server 2008. Full text is built into SQL Server service itself, so there is no additional full text service. Okay, so these are some of the account considerations, which pretty much same as Windows SQL Server 2003, except for one thing, SID. We'll talk about that. So, so you need to have a domain account. You need to have a separate, for security reason, we recommend having separate domain account for each service account. One for SQL Server service, agent service, browser, so on and so forth. For installing SQL Server 2008 on Windows 2008, you don't need those domain groups. Remember, when you're installing SQL Server 2005 on Windows 2003, you need to create domain groups. At some point of the setup, SQL Server is going to ask you, give me the domain groups that I need to use. So SQL will use those groups and apply all the permissions to those groups. So, when you change services, things like that, there is no problem with that. So there is no need of domain groups anymore in SQL Server 2008 because it's all now SIDs, security identifier. It's a Windows 2008 concept where the individual services need not have, well, they can have a service account, a domain account or Windows account, but in addition to that, it also has this concept called SID. So each service has its own SID, security identifier, that will have all the privileges required for running that service. So even if you are changing the service, the SID is going to be the same, so you don't need to worry about applying the appropriate permissions, privileges and all that. Not only that, the SID is going to make sure that your services are isolated. So if you're using same account for multiple services, you have the security hole there because because the same account, it has same permissions, so each service can exploit the others. But with the SIDs, everything is isolated. So that SID used by that one service can only use that service and work with that service, not with any other service. So the SID concept is including, so if you are installing Windows 2008, SQL Server 2008 on Windows 2008, it is not going to, you can still provide domain groups, but recommended is SIDs. So it's not mandatory to have domain groups. Okay, so these are the permissions. Again, no change here. Same permission for agent and SQL Server service you need to provide. So these are the pre-install requirements. So you know about network disks and configuring the failover cluster. By the way, installing the failover cluster in Windows 2008, it's now using features. So it's a Windows failover cluster is a feature. So you need to go through Windows. It's not built in. Like in Windows 2003, cluster is built in by default in Windows 2003. All you need to do is run cluadmin and start creating your cluster. But cluadmin is not available by default in Windows 2008. You had to install this feature only then, because not all servers you want to create as clusters, right? So why having it by default like Windows 2003? So it will not be installed until you actually want it. So when you want to create a cluster, you have to run the features. You can do it through Server Manager or the what is it called? Initial configuration. There is a window that opens up when you install Windows 2008. So in that you can select that I want to install cluster, and it can do all that. And these are the prerequisites for SQL Server. So you need to install .NET Framework. You have to manually do it. SQL Setup is not going to do it for you. So .NET Framework, Windows installer are the installation prerequisites. And then file stream patch. If you are installing SQL Server 2008 on Windows 2003, you also need to install this file stream patch. Even if you are not using file stream, you have to install, otherwise your setup will not go. And then setup support files, which will be installed by setup. But the .NET Framework, Windows Installer, and file stream, you have to install. All right, so these are all local disks for installing the binaries. These are all the prerequisites for SQL Server. Another difference here is compared to SQL Server 2005. In SQL Server 2005, when you are installing SQL Server, it only lets you choose one disk, though you have multiple disks, because we recommend having multiple disks for SQL Server, right? One for data, one for logs, one for TempDB, or multiple for data, multiple for TempDB. But when you're installing SQL Server 2005, we only allow you to select one disk where all your system data files are going to be. Then you have to add all the remaining ones. But with SQL Server 2008, we let you choose multiple disks. 1 minute? Yes. Yeah, we let you choose multiple disks, so you don't have to again take a downtime and start adding all the extra disks. You can do all that at the time of the setup. So by the end of the setup, you will have all those disks available in your cluster group. And unique virtual name, these are all same. Okay, so I'm going to talk about this slide and stop. Okay, so these are the two ways to install SQL Server 2008 on a cluster. So like I said, there is no default way of doing it. There is no unattended installation. SQL Server setup is not going to install on all the nodes. You have to individually do it. And there are two ways to do. The most common one is integrate install, where so you install on one node. So you take the first node. So let's say you have 4-node cluster. On the first node, you run the setup and say create single node failover cluster. So it's going to create a single node failover cluster, and then it's going to, let me show you this graph so it is easy for you to understand. Okay, so let's say you have a 4-node cluster on a 4-node Windows cluster. You first run the setup on the first node and select create a failover cluster. At the end of this setup, you have one single node cluster. Unlike in 2005, where by running one setup on one node, all the other nodes will be added automatically. But that's not there anymore. So at the end of this, you have one single node cluster, and then you run the setup on each of the other nodes, and then you say add node to the same cluster. You have to provide the same cluster name and everything. So then you say add node. So at the end of this 4 installs, so you did 4 installs. At the end of this, you have a 4-node cluster. So that's the integrated install. The other one available is, which is not very common, is the advanced or enterprise install. This is more advantageous when you have more number of 16-node cluster and you want to do an automated install or something. Then you can do a prepare phase. I'll show you a graph on that in the live meeting. So you do a prepare phase where on each node you install just the binaries. So at the end of each of those setups, you still don't have a cluster. You don't have not even a single node cluster, unlike an integrated install. So you had to prepare on each node. Let me show you that graph real quick so it's easy to understand. Come on. Yeah, so here, so you have a 4-node cluster. So you do a prepare phase first. So in the prepare phase, each node will get its own binaries on each node. It can be automatic, like you can do any third-party tools to push the binaries to each of the nodes. And at the end of that, you do one time a complete phase, at which time it is going to join them all together and make a cluster. So at the end of phase 1, prepare failover cluster, you don't have a cluster at all. You just have binaries on each node. At the end of complete, the complete takes like few minutes. And it's a manual thing you need to do. So at that phase, after the end of that phase, you will have a full node cluster. So when you have multiple nodes and you don't want to run integrate install on each node individually, manually, you can push all the binaries to all the nodes, and then you have to do one time a complete phase to get the entire cluster available. So that's the enterprise or advanced install. All right, so let's stop here. Again, I'm sorry I'm not able to show you any demos, but I promise you that we are going to set up a time. I'll work with Sri to set up a live meeting to show you.
I would say you set up a time, you record the live meeting and send us all the link out. So
Oh, okay.
that way, and everybody doesn't have to physically,